Space exploration is poised for a dynamic decade of innovation, cooperation, and potential milestones in both robotic and human missions. The primary drivers of this progress include advancements in technology, increased private sector involvement, and renewed governmental ambitions. Here's a detailed exploration of the trends, priorities, and projected courses of action for the next 10 to 15 years. The Moon is set to become the centerpiece of space exploration over the coming years. Multiple nations and private companies have announced ambitious lunar missions, marking a revival of the excitement seen during the Apollo era. The key initiatives include NASA's Artemis program. The Artemis missions aim to establish a sustainable human presence on the Moon by the 2030s. Artemis I, an uncrewed test flight around the Moon, has paved the way for Artemis II, which will carry astronauts. Artemis III, expected in the mid-2020s, will see humans set foot on the Moon's south pole. Beyond landing missions, Artemis will work on constructing the Lunar Gateway, a small space station in orbit around the Moon, serving as a hub for exploration and science. International collaborations. The European Space Agency, ESA, Japan's JAXA, and Russia's Roscosmos, among others, are contributing to lunar programs through landers, rovers, and modules for the Lunar Gateway. China and Russia have proposed a joint International Lunar Research Station, ILRS, aiming to establish a robotic base by the mid-2030s. Commercial involvement. Companies like SpaceX, Blue Origin, and Robotic are developing lunar landers and logistic support. SpaceX's Starship is a key vehicle for Artemis landings, and Blue Origin's Blue Moon lander has been developed for NASA's Human Landing System, HLS program. Mars remains the long-term target for human space exploration. However, reaching the red planet presents immense challenges in terms of technology, finance, and safety. Key developments and missions include NASA's Mars program. NASA's Perseverance rover is currently conducting the first phase of a Mars sample return mission, collecting and storing samples to be returned to Earth in collaboration with ESA by the early 2030s. This would provide unprecedented data on Martian geology and potential biosignatures. Human missions by 2040. NASA's Artemis is a stepping stone for Mars missions. The goal is to send astronauts to Mars by the late 2030s or early 2040s, leveraging lunar experiences to prepare for the complexities of a multi-year round-trip mission. Private ventures. Elon Musk's SpaceX aims to lead the charge with its Mars vision. The company's Starship spacecraft, currently under development, is designed to be fully reusable and capable of carrying large crews and cargo to Mars. While optimistic projections suggest Mars missions by 2030, technological hurdles remain significant. Low Earth orbit (LEO) is evolving rapidly as both a commercial and research hub. The International Space Station (ISS) is expected to be retired by 2030, making way for a new generation of space habitats. ISS transition and commercial space stations. NASA is working with private companies to develop commercial LEO destinations. Axiom Space, for instance, plans to build its own module connected to the ISS, which will eventually serve as a standalone station. Other companies, like Blue Origin and NanoRacks, have announced concepts for LEO stations designed for tourism, research, and manufacturing. China's Tiangong Station. China's rapidly developing Tiangong space station will be completed in the coming years, offering an alternative research platform. It will be open to international partners, although geopolitical considerations will shape who participates. Protecting Earth from potential asteroid impacts is gaining traction as a key component of space exploration. NASA's DART mission and follow-up. The successful double asteroid redirection test DART in 2022 demonstrated the ability to alter an asteroid's trajectory. Future missions such as Hera, led by ESA, will further study the results of DART and improve our understanding of asteroid deflection. Resource utilization and asteroid mining. Companies like Planetary Resources, now defunct but influential, and NASA's own efforts with missions like OSIRIS-RX, which recently brought back samples from asteroid Bennu, highlight the interest in asteroid resources. While large-scale mining remains a future possibility, It could someday support in-space manufacturing and fuel depots. Robotic exploration will continue to lead efforts in the outer solar system, with several high-profile missions on the horizon. Europa Clipper and JUICE missions. NASA's Europa Clipper, launching mid-2020s, and ESA's JUICE, Jupiter Icy Moons Explorer, will explore the potentially habitable environments of Jupiter's moons, searching for signs of subsurface oceans and, potentially, life. The Dragonfly mission to Titan. Launching in 2027, Dragonfly is a rotorcraft that will explore the complex chemistry of Titan, Saturn's largest moon, which features lakes and rivers of liquid methane and ethane. New Horizons and future interstellar probes. As the first spacecraft to fly by Pluto and explore the Kuiper Belt, NASA's New Horizons mission is still sending back data from the fringes of the solar system. Proposals for interstellar probes aim to extend our reach beyond the heliosphere and into true interstellar space within the next few decades. The rise of private space companies has democratized access to space and led to a boom in commercial activities. Suborbital tourism. Companies like Blue Origin and Virgin Galactic are now offering short trips to the edge of space, giving civilians the chance to experience microgravity and stunning views of Earth. Orbital tourism and commercial missions. SpaceX has led the way in orbital tourism with its Inspiration 4 and Axiom space missions, which send private citizens and non-professional astronauts into LEO. As costs decrease, more private orbital and even lunar missions are expected. The geopolitical landscape in space is evolving. While international cooperation has been a hallmark of space exploration since the ISS, new challenges are emerging. The rise of China. China's ambitious space program has placed it as a formidable player in space. From the Chang'e lunar missions to Mars Tianwen-1 mission, China is advancing rapidly. Its exclusion from the ISS has led to the independent development of the Tiangong station and proposals for joint lunar missions with Russia. New space treaties and governance. The Artemis Accords, led by the United States, aim to establish norms and rules for lunar exploration, including resource extraction and safety zones. However, not all spacefaring nations have signed on, indicating potential future disagreements over space governance. Despite the optimism, significant hurdles remain. Technological hurdles. Long-duration human missions to Mars require breakthroughs in life support, radiation shielding, propulsion, and human health. Similarly, reusable launch systems and in-space manufacturing need further development. Funding and policy stability. Large-scale space missions require sustained funding and political support. The multi-decade timelines for Moon and Mars missions mean they are vulnerable to shifts in political priorities. Ethical and legal considerations. As nations and companies eye lunar and asteroid resources, the lack of clear legal frameworks could lead to disputes. Ethical questions about human settlement, planetary protection, and the use of space resources will need to be addressed. The next 10 to 15 years will be transformative for space exploration, with the Moon serving as a near-term focus, Mars as a long-term goal, and LEO evolving into a bustling hub of commercial and international activity. The outer planets, asteroids, and deep space destinations will continue to inspire groundbreaking robotic missions. As technological capabilities expand, space exploration will shift from an exclusive domain of superpowers to a more collaborative, diversified endeavor, bringing humanity closer to becoming a multi-planetary species.